Okay, welcome to my third video in transformers. Now I'm going to show you what is the impedance transfer in transformers, why do we do that, and if you didn't watch my previous videos where I showed you what is an ideal transformer and what are the equations in an ideal transformer, please watch that because it's gonna be easier for you now to understand this. So when we have a transformer, for example an ideal transformer, I told you what are the equations by V1 and V2, what is the turn ratio in my previous video, and so on and so on. Now the voltages induced here are in an ideal transformer don't depend that much in an ideal transformer from the impedance. Of course that is not true, it depends, but let's say it doesn't depend right now. But the current here, I2, is limited by this impedance Z2 right here. So the impedance in alternating current is defined by the Ohm's law, that is equal to the voltage on that some consumer divided by the current that goes through it. Now we can put a resistor, we can put some inductance, capacitance. I would say now imagine this, that this here is just a resistive part, not reactive. Okay, so the Z2 is equal to the voltage divided by the current, and this current is going to be equal to V2 divided by the impedance. So the higher the impedance, the smaller the current. But in my previous video I showed you that when we have a current I2, then this source V1 is gonna draw a current in the primary. So in an ideal transformer there was no exciting current, but when we put an impedance, then the current I1 started to go in the primary. Okay, now I hope you remember that. Now if we have voltage and we have a current, then we have some kind of impedance. Only in superconductors you don't have any impedance or resistance, but this is not the case. We always have some resistance, impedance. Even in ideal situation like this, you can make that like something fictional. So we have an input impedance here, Z1 in the primary side of the transformer, which is also by Ohm's law equal to V1 divided by I1. So I think you understand this part. Now remembering some equations, that V1 divided by V2 is equal to A, which is equal to N1 divided by N2, and that A is called the turns ratio. Now from this you can see that V1, the voltage on the primary, is equal to A times V2. Looking at this here equation formula, and in my previous video I showed you that I1 divided by I2, the primary current divided by the secondary current, is equal to 1 divided by A, and that leads us to this here equation, that the primary current is equal to the secondary current divided by the turns ratio. Now if you put this here, that V1 is equal to A times V2, and if you put that I1 is equal to I2 divided by A over here, you get that Z1, the input impedance here, is equal to A times V2 divided by I2 divided by A. So this is a double fraction, and A are multiplied, and you get A squared, that is equal to V2 divided by I2. V2 divided by I2 is the secondary impedance. Here you have it, and this Z1, the input impedance, which is in this particular situation depended by the Z2 here, is equal to A squared, the turns ratio squared, times Z2. Okay, now I copied this and this here, and this here, A squared Z2, here is equal this Z2 prime. So this here is the transferred impedance on the primary side. So if you're from the primary side, this impedance is equal to Z2 prime, which is equal to A squared times Z2. Now, why do we do that? What is the Z1 and Z2 have a connection, they have a relationship which is equal to this A squared. So this is the equation, so this is the relationship between Z1 and Z2 prime. Now, why do we do this impedance transfer? Well, for example, here we have a transformer. These two bars represent the magnetic bars, the leg bars of the magnetic circuit, the tight coupled ferromagnetic material. Now, with this impedance transfer, we can transfer this Z2 on the primary side, which is equal to Z2 prime. And then we get this kind of schematic over here. Why do we do this? Well, because it is easier to calculate all the parameters, voltages, induced, the power only in one circuit, not like this. So we don't use these circuits. It's very useful for us to do these transformations from the secondary to the primary. And if you want, so the impedance on the looking from the primary side is Z2 prime, which is equal to A squared times Z2. Just a second. So Z2 prime is an impedance looking from the primary side, and then we get a simplified circuit over here. Okay, now and if you want to transfer from the primary to the secondary side, then Z1 prime is the impedance transfer from the primary to the secondary, and is equal to 1 divided A squared times Z1. But usually we do from secondary to the primary. But also here we can also do this. Now, I hope you understand a little bit about this impedance transfer. In my next video, I'm gonna show you one example, and I think that's a good example with some speaker, and you will see. In my next video, this is gonna be more understandable for you. So thanks for watching. I hope now you know what is an impedance transfer, and see you in my next video where we are going to do some example with this. See ya and have a nice day.